Hello all, my name is Grace. On behalf of everyone who works on Codegoda, welcome you to the Codegoda 2022 award ceremony. We're glad to see Codegoda evolving every year from 2019 when we first took the programming competition externally, and this year we've brought together over 49,000 coders from 72 countries and celebrated women in tech. We provide a space for programmers at all levels to have fun, and we hope you enjoyed the competition as much as we did. And more importantly, we hope you've learned more about problems we're facing as a travel platform, look at them from a new perspective, and find a way to optimize your solutions. This is how we as Agoda improve technology and innovate things. And now, let us share with you a bit more about who we are. Let's hear from Idan, our CTO.
Now let me tell you a bit about our tech team at Agoda. Now we often say that Agoda is a technology company that happens to do travel. We believe that technology is the best enabler and driver for the business, and that's why we invest so much in it. And that's why you will see us using the most modern architecture and technologies, even if we're a 20-year-old company. We use the latest tech, whatever it is, microservices, micro frontends, data mesh architecture, or we use the newer languages like Kotlin or Go, or .NET Core, and leveraging modern DevOps practices like building automated Kubernetes clusters and power a private cloud that working with Istio and other newer technologies. We build our own data monitoring platform and feature store and many more tooling that help us really push forward. But the real challenge is not just to do all these things that I just stated, is by doing them in scale. Now, to give you some reference numbers, what I mean by scale, we have about 500,000 CPU cores. We have thousands of deployments going on every day. We have 1.5 trillion messages on Kafka every day. And it all comes to a 40 petabyte data lake of compressed structured data. And on top of that, we are doing billions and billions of real-time machine learning predictions in every day. And this is the reason why we need to have the best people that are actually excited about these kind of challenges. And whether you are an Android dev or a data engineer or a full stack, we likely have something interesting for you to work on. Now, about our culture, we really value independent teams that can take on problems and take them from the start to the finish and have full ownership. And of course, on top of that, there's the bonus of getting to live in Thailand, which I personally have been doing in the last 8 years, and I would recommend it to anyone.
Thank you, Idan. Please, everyone visit careers@agoda.com to check our open roles in the tech team. And next up, Satendra will walk you through the code problems.
Thank you, Grace. So today I will go over one of the questions from Codegoda. So let's look into the merge and break. So the problem says that you have n distinct arrays and you have to create a sorted array out of it. You are given two operations. You can merge or you can break. Each has a cost function. So when you break, you can split an array x into x1 and x2. And the cost of this operation is the minimum of the size of x1 or x2. And for merge, you can merge x1 and x2 into x. And the cost of this operation is the sum of the length of this array. Right? So let's first discuss the approach to solve the problem, and then I will show you the code. So the first thing that comes to my mind is the cost function for merge operation. Given that it takes the size of the arrays, I would try to make sure that I split the array into smallest pieces. So I can optimize the cost of merging. So let's first focus on breaking the array. Now, given the goal is to get a sorted array, we will try to see where the array becomes unsorted. Like when the next element is smaller than the element, like a of I is greater than a of I plus 1, and that is the place where you need to split in the array. But given that there is a cost function which says that the cost will be of the minimum of the size of the smallest split, we want to make sure that we split the array towards the leftmost or towards the rightmost, right? So let's try to understand this with an example. Let's say that you have an unsorted array, right, of size 3. So you have 3 to 1. So here you can split this into 3 and 2, 1, and then again break 2, 1 into 2 and 1, right? So you will eventually get 3 splits, each of size 1, 1, 2, and 3, and then you can start merging, right? So here the total cost of the break operation is 2, right? And this is equal to the size of the array minus the maximum size of the split. So in this case, the maximum size of the split is 1, right? Let's try to understand this with another example. So let's take a totally sorted array, right? So let's take an array of size 4, 1, 2, 3, 4, right? So given this array is already sorted, you don't need to break it. So you have only one split of size 4. So here the size of the array minus the maximum size of the split, this becomes like a 0. So there is no cost of breaking, right? So if you run this through multiple examples, and this becomes clear that the cost of the break function is size of the array minus maximum size of the split. Okay. Now let's look into the merge operation. So you can visualize this with a tree, right? So where the leaves are the split arrays, and the intermediate nodes are the merge nodes, right? So when you merge two split arrays, you get these intermediate nodes. Now the cost of merging is the depth of the tree multiplied by the size of the node, right? So if you think about it, this helps you understand that, you know, towards the depth of the tree, you want to keep the smallest split sizes, right? So that would minimize the cost of merging the split arrays, right? So once this becomes clear, then the whole problem is very straightforward from here. That eventually we need to take two smallest arrays and then merge them, and then keep on repeating. So this can be done using a priority queue, right? So you implement it using a heap, where you take two arrays, merge them, put it back on the heap, and then repeat the process till the time you get the single element in the heap, right? So now let's look into the code. So what I have done is, after understanding the problem, I'll first, I worked out through the test cases and described the algorithm. This I showed to you previously. Now if you go into the code, here it's very straightforward. You read the input and try to get the total cost. And here you first find the splits and get the cost of breaking. So first you have to find the points at which you can split. So here you try to see, where my array is getting unsorted. And the next part, what I'm doing is calculating the size of each split, right? And then, as I was describing before, that the cost of breaking is the length of the array minus the maximum size of the split. After that, we get into the merge. So in the merge part, we put these splits, and one point to note here is you don't really have to put arrays, right? You just need the size, because eventually we just need to calculate the cost. So you put this size of the split into the heap, take two elements from the heap, merge them, and then put the merged one back to the heap. So eventually you will get the total cost of merge and break. Now let's run this to see if the code is working fine. So yeah, let me put this test cases. So as we see, we get 7 and 9, which are the right output. I hope I was able to clarify this question to you, and hope you understood the solution. We will publish solution for all the problems on our engineering blog. Thank you.
Thanks, Satendra, for walking through the problem. And now is the moment everyone been waiting for. Let's see who the winners are.
Just one thing before we start. We're aware of inaccurate feedback on a correct solution within one of the questions. Rest assured, coders with the right solution who completed the full test were marked accordingly. And now let's move on to the important part.
Let's start by announcing the special prize for the top woman coder of Codegoda 2022. Congratulations, Mansi Homraj from India. You have won $500. Now Max and Hada will tell you who the top 10 are.
Thank you, Zainab. I'm happy to announce 10th to 1st places. Big congratulations to all of you. You all achieved impressive scores and therefore you won $250. Congratulations.
Up next, the 3rd and the 2nd places. Nguyen from Vietnam, you won $1,000. And Nikita from Germany, you won $2,000. But there is one guy that beat you all with the speed. Anirudh from India, congratulations on winning Codegoda 2022. We know it was not easy, so congratulations to all our top winners.
Now, last but not least, congratulations to all the top 100 programmers. All of you won a Codegoda t-shirt. The full list of winners is now live on codegoda.io.
Thanks everyone for participating. I know it was extremely challenging to solve problems fast and well. At Agoda, we value moving fast as one of our core values, so it's something we really enjoy doing every day. If you're looking to be surrounded by similar-minded people who love technical challenges, fast pace and huge scale, all you need to do is apply to Agoda. Thanks again for joining and good luck everyone. We hope to meet some of you in the future.